AB Calculus Note Card 30, L'Hôpital's Rule. This is the 30th note card lesson inspired by Stacy McMullen, formerly the Dallas Independent School District. This is the word in French for hospital, but in French there's a little hat accent over it called the accent circonflexe. Anyway, this L'Hôpital's rule is used to evaluate limits that are of indeterminate form, such as 0 over 0. So if you go back to note cards 2 with limits, and then note cards 3, which is analytical methods for determining limits, okay, that's where you really can't factor to take care of things. L'Hôpital's rule comes in very handy. And what you do is the limit as x approaches a of any function, of a function g of x, f of x over g of x, if that is 0 over 0 especially. It could be occasionally infinity over infinity, but mainly you see 0 over 0, is the limit as x approaches a of f prime of x over g prime of x. And you can take successive derivatives too. If f prime of x over g prime of x still gets you with 0 over 0, you can keep on taking a successive derivative until you get a numerical answer, in which case you're going to have a limit. We're going to work out some problems, and a lot of these problems come from the BC test and not from the AB test. The AB test only started giving problems for which L'Hôpital's rule was required only a couple years ago. So anyway, let's take a look at these. The limit as x approaches 0 of sine 2x over sine x, and the first thing you try to do is substitute in. So if you substitute in 0, you're going to get sine 0 over sine 0, and the sine of 0 is 0. Okay, so we call this indeterminate form, and we call this more work. Okay, but we're going to take the derivative of the numerator and the denominator, and so the derivative is going to be, I'm just going to continue to write limits below. Limit as x approaches 0 of, what is the derivative of sine x? Well, it's going to be the cosine of 2x times the derivative of the inside, which is 2. Okay? And then in the denominator, your sine, derivative of sine x is cosine x. And so now if we substitute in 0 in the numerator, we're going to get 2 times cosine of 0, because 2 times 0 is 0, over cosine 0. Well, the cosine of 0 is 1, so we're going to get 2 over 1, which equals 2. And so this is one of the special trig limits if we go back into an earlier note card, but our answer for this one is 2. 2, the limit as x approaches infinity of natural logarithm of x over x. Now notice that we are not approaching a real number, we're approaching infinity, which is, if there is a limit as x approaches infinity, this is going to qualify as a horizontal asymptote. And what happens for the analytical methods here, we have what we refer to as your bigger on bottom, because what's happening is the x to the first power in the denominator is going to get bigger faster than the natural logarithm of x in the numerator, meaning that as we go on toward infinity, we are approaching 0, so the answer to this limit is 0. So we would say the horizontal asymptote is going to be the equation y equals 0. Another way of saying the same thing. 3, the limit as x approaches 0 of x minus sine x over x cubed. And we're going to try first of all by plugging in 0. So if we plug in 0, we get 0 for x minus sine x, which is sine 0. So we get 0 minus 0. And then in the denominator, we're going to get x cubed, or 0 cubed. So we're going to get our indeterminate 0 over 0 again. So now we're going to go ahead and try the L'Hopital's rule. So limit as x approaches 0, we're going to take the first derivative of the numerator, which derivative of x is 1, and the derivative of sine x is going to be cosine x. And in the denominator, we take our first derivative of x cubed, which is going to be 3x squared. And if we plug in 0, we're going to get 1 minus cosine 0 over 3 times 0 squared. Well, in the numerator, we're going to have 1 minus 1, which is going to be 0. And in the denominator, we have 3 times 0 squared, which is also 0. Okay, let's try another differentiation. So we have the limit as x approaches 0 of what is now going to become the second derivative of the numerator. And so the derivative of 1 is 0, and the derivative of cosine x is going to be sine, going to be positive, because the derivative of cosine becomes negative sine. So this negative sign is canceled out by another negative sign. So we're going to have sine x over, taking the derivative of 3x squared in the denominator. We're going to have 6x. And if we plug in 0 for this, we're going to get sine of 0, which is 0, over 6 times 0, which is 0. Okay, let's try it again. Limit as x approaches 0 and the derivative of sine x is going to be cosine x. And the derivative of 6x is going to be 6. So if we plug in 0, we're going to get cosine of 0, which is 1, over 6. So that is our answer, 1/6. Next, 4, which is from a previous BC calculus test. So we have the limit as h approaches 0 of e to the h minus 1 over 2h. And what I would like to do is, this h seems kind of strange here, so I'm just going to rewrite this as the limit as x approaches 0 of e to the x minus 1 over 2x. So we're just making a more standard looking variable here. And if we plug in 0, we're going to get in the numerator e to the 0 power minus 1 over 2 times 0. And so e to the 0 power is 1, so in the numerator we have 1 minus 1, or 0, and in the denominator we have 0. So that's going to be indeterminate, and so we're going to go on below. So we're going to take the first derivative of the numerator and the denominator. So the limit as x approaches 0 of derivative of e to the x is going to be e to the x. And the derivative of 1 is 0, so we just have e to the x left. And in the denominator, we have the derivative of 2x, which is 2. And so for this, if we plug in 0, we're going to have e to the 0 power over 2. And e to the 0 power is 1, so we're going to get 1/2. So 1/2 is our correct answer for problem 4. Next, problem 5. Consider differential equation dy dx equals y squared times quantity 2x plus 2. Let y equals f of x be the particular solution to the differential equation with initial condition f of 0 equals -1. And then find the limit as x approaches 0 of f of x plus 1 over sine x. Show the work that leads to your answer. Okay, we're really going into the future. We don't have the basis to fully be able to do this based with the previous note cards up to this note card 30 lesson. And we're going ahead to note card 56, which is particular solutions. And also to note card number 75, which is differential equations. Yet this problem is a good one for testing for using L'Hopital's rule. So let's go ahead and work this out. So bear with me if this does not seem too familiar to you. The first thing we're going to do with the differential equation is, I'm just going to write it down here, dy dx equals y squared times quantity 2x plus 2. And when you get a problem like this on the free response AP test, you get 1 point for doing a number of different things. And the first thing you're going to try to do is, after being given a differential equation, is separate the variables. And so what we're going to do here is we're going to divide both sides by y squared and multiply both sides of this equation by dx. So what we're going to get doing these two things simultaneously, we're going to get dy over y squared is equal to 2x plus 2 dx. So now we've separated the variables. In an AP test, this would give us 1 point just for this alone. So next we're going to I'm going to write this in calculus-friendly form. I'm going to say y to the -2 power dy equals quantity 2x plus 2 dx. And now we're going to go and get an equation for this in terms of y, work toward anyway, by integrating both sides of this equation. And so we're going to look for the integral, which is the antiderivative of each side. And the antiderivative of y to the -2 power dy is we raise that, we add 1 to -2, so we're going to get y to the -1 divided by -1, which is going to be the same as multiplying by -1. And on the right side, we're going to take the antiderivative of 2x, which is going to be 2x squared over 2. So that 2 over 2 is going to cancel here. And then we're going to have plus 2x. And in making a indefinite integration, we're going to also have to add a constant, which is going to be plus c. And so what we have is y to the -1 power, or actually negative y to the -1 power. So we're going to have, I put -1 over y is equal to x squared plus 2x plus c. And then we can flip this thing upside down, and we're going to get negative y is equal to 1 over x squared plus 2x plus c. And then finally, we're going to just solve for y by switching the negative signs. So we're going to have y is equal to negative 1 over x squared plus 2x plus c. Now what we're going to do is take our initial condition, f of 0 equal negative 1. So we're going to substitute in 0 for x, and put the right here, x. Okay, x equals 0, and y equal negative 1. So let's go ahead and do that. We have negative 1, because that's going to be y, equals negative 1 over x is 0, so we get 0 squared plus 2 times 0 plus c. And negative over negative will cancel each other, and so we get 1 equals 1 over c. And then if we solve for c, we're going to get c is equal to 1. And now we can take this 1 back up here, replacing this c over here, and get a particular solution. So I'm going to bring this up here below where it says show the work. Let me just write an arrow up here. So we're going to have negative y. I'm just going to use the y is what I'm going to do instead of the negative y. Y equals that. Y equals negative 1 over x squared plus 2x plus 1. So this would be our particular solution right here. And you get points all along the way for this. And this is our f of x, essentially. So what we're going to have is, it says find the limit as x approaches 0. And so we're going to have limit as x approaches 0 of f of x, which is negative 1 over x squared plus 2x plus 1, and then that's going to be f of x plus 1 over sine x. And for that, just kind of working, where do I want to work? I guess I'm going to work below. If we plug in 0, now I'm going to work to the right because we can just plug in 0. We're going to get negative 1 over all this in the, if we plug in 0 for x, we're going to get negative 1 over 1 plus 1. That's going to be 0 over sine x, and sine of 0 is 0. So we're going to get our indeterminate form, 0 over 0. So now we can differentiate the numerator and the denominator, and differentiating this negative 1 over x squared plus 2x plus 1, we can write that as x plus 1 quantity squared, can't we? So we have the limit as x approaches 0 of -1 over x plus 1 quantity squared plus 1, and then we have sine x. And now we'll just take the derivative of both of these. So before taking the derivative, let me work to the right here. Limit as x approaches 0. And I'm going to write this as, in the numerator, -1 times x, quantity x plus 1, to the -2 power, because I brought this as a denominator, plus 1, over sine x. And now taking the derivative, I'm going to work, I guess I'll continue to work to the right. The derivative of this we're going to have -2 times 1, right? So -2 times -1, we're going to get 2, and we're going to get x plus 1 here, times the derivative of the inside, and we're going to subtract 1 from this deriving, this -2 becomes -3, -3 power, and this becomes 1 here, this plus 1. And then in the denominator, the derivative of sine x is cosine x. And now if we plug in 0, we get, now I'm going to just continue working below here. We're going to get limit as x approaches 0 of, well, we'll just plug in 0, see what we get. That's what I'm going to do. We're going to get 2 times 0 plus 1 to the -3rd power over cosine 0, which is 1. And 1 to the -3rd power, okay, that's going to be 1 over 1 to the 3rd power. That's going to be 1 to the -3rd power. So we're going to have 2 over 1, which equals 2. So our answer to this is 2. Quite an advanced problem. The Hopital's rule problems you're probably going to see on the AP test are going to look more like these 1 through 4. Good luck on all your problems, and thanks for viewing.